All right, page 37 in your textbooks, you did the homework section, numbers 1 through 15. You also did the homework section, numbers 1 through 8, at the top of page 40, page 40, numbers 1 through 8. You weren't here. There's 1 through 8 and 1 through 15. Excellent. 1 through 15 and page 40, 1 through 8. 1 through 8's there on paper, and 1 through 15, excellent. Uh-oh, what happened? Oh, okay.
But I did do this.
You got the 1 through 8 at least, okay. Good, let me see that again. Excellent, good, and page is falling out, uh-oh. All right. Ah, checking out the bottle. Yeah, page 41, or page 41, 1 through 8. And there's the 1 through 15.
Oh, so I did.
It is page 41, no lie.
Yay, I did it right.
Yeah, I might have typed something wrong in my notes, that's all. And then page 41 through 8. There's the 1 through 15. And the 1 through 8's on the back. All right. Did you find it, Michael?
On what?
The page 41, 1 through 8?
No.
No. And Jalen, I'm going to check that other assignment from yesterday after class. So just come see me afterward and I'll take a look at yesterday's assignment. All right, let's take a look at page 37, numbers 1 through 15. Number 1, what group of numbers includes positive and negative whole numbers and 0, Jalen?
Integer.
Integers. What's the value of the absolute value of negative 12, Bryson? 12. Number 3, when you wrote those from least to greatest, what did you put, Kirsten?
Negative 7.1, negative 3, 4 and 4 ninths, 4.23 and 5.
The only one you left out was 0, which was right in the middle of all of that. So negative 7.1, negative 3, 0, then your 4 ninths, your 4.23, and your 5. So you had the right order, you just forgot to include 0 in it. Number 4, what is the prime factorization of 150 if we use exponents? What did you have for that one, Sam?
2 times 3 times 5 times 5.
But it said using exponents, so...
2 times 3 times 5 squared.
Good, 5 squared, good. 2 times 3 times 5 squared is correct. Number 5, which of those are prime numbers? Luciana?
37 and 41.
Good, 37 and 41. The other ones, like 56, 22, you know there's a 2 in there because they're even. There's at least a 2. And 69, you should be able to see the 3 that's in there. So those ones can't be prime, but the other 2 are prime. Number 6, it said to find the GCF of 120 and 140. Now, you might be able to just look at them and you already know the greatest common factor. It is kind of hollering at us here, but let's suppose we didn't see it. One way to find the greatest common factor, remember, is to prime factor. What's a way we could split up 120? Just a nice, easy way to split that up. Jalen?
12 and 10.
12 and 10. Should be looking us right in the eye. And of course, the 12 could factor Paige into...
2 and 7.
but the 6 could then factor into...
2 and 3.
And the 10, of course, could factor into Griffin. 2 and 5. If you wanted to, of course, you could scribble out all the composite numbers. So how would I write the factors of 120, Jalen?
2 cubed times 3 times 5.
2 cubed times 3 times 5. I actually like writing it out as the 2 times 2 times 2 times 3 times 5 when I'm trying to look for what's shared. It's not a problem to use the exponent at all. I just find it easier to do it that way. For the 140, what's the easiest way to split a 140, Michael? Michael?
I didn't do that one.
I don't care. Look up this way and tell me what's the easiest way to split a 140. I don't care if you did it or not.
5 times 7. I mean 2 times 70.
I mean, you could. I was thinking 14 times 10, but 2 times 70 works. What's a good way to split a 70 then, Michael?
2 times 35.
You could. I was thinking 7 times 10, but you could do 2 and 35. What's a good way to split 35?
7 times 5.
7 times 5. Okay, I knew to get that one. Okay, so what are the prime factors of 140, Michael?
2 times 2 times 7 times 5.
Okay, normally it's 5 times 7, but that's fine. What do they share, class? What is common to both of these? Ben?
2.
They have a 2. What else?
5.
They have a 5. Another 2. If I can circle it all. That's it. That's all they have in common, right? So 2 times 2 times 5, class, means the greatest common factor is?
20?
And let's be honest, couldn't we all see 20 times 6 and 20 times 7 already? Most of us probably could. But that's how we would approach it if we couldn't see that. Or if we just wanted to be sure, prime factor, find what is shared. Let's see, number 7 says to multiply 13.87 by 10 to the 4th. What's the shortcut here? What's the easy way to multiply by 10 to the 4th? Paige?
Just add zeros?
Well, not necessarily add zeros, but move the decimal point. How many places do we have to move the decimal point here, Paige?
4?
4 places. Which direction, right or left? Because it says to
Right.
multiply.
Right?
To the right. We multiply right, we divide left, remember, Mr. Driver's License. So we move it 4 places. 1, 2, 3, 4. Now, Paige, you're not wrong. We do end up adding zeros. How many?
2?
Only 2, though. We don't add 4 zeros, we add 2 zeros. So what's the number now that the decimal's all the way back there now? Class?
138,700.
138,700 should have been our answer there. Number 8, what did you put in the blank, Sam? Let's see, from your perspective, this one or that one? The first one or the second one? The first one, less than. Okay, that's how we read it, less than. -8 is less than -6. How about number 50 or number 9? Excuse me, it has 15s in it. Number 9, Sam. They're equal. And then what about number 10? Is greater than. So the mouth opens to the 17. So a greater than symbol in the blank for number 10. Word of operations. Curious to see how we did. These were tricky. These were a little challenging. So I'm curious how we did. Number 11. What did you get, Paige?
32.
32 is correct. Number 12. What did you get? Elaine.
55.
55 is correct. Number 13. Jalen.
25.
25. How many went 3 for 3 on those? How many went 2 out of 3? You only missed one of them. All right, which ones do we need to see worked out? I'm willing to work all 3 of them if we need all 3 of them. Which ones did we miss and need to see worked? Hands. We missed 1 or 2 or 3. We're not sure. Sam, which ones? 11? Yeah, let's take a look at 11. It's a big, nasty one. The key, remember, is to wait till the end to do addition, subtraction. Unless, of course, it's in class parentheses or some kind of grouping symbol. In this case, they do use the parentheses. So the first thing we have to take care of is the parentheses or the grouping symbol, but within the grouping symbol here, I've got 2 exponents and an addition. Of those 3 things, class, the first thing I need to take care of are the exponents. So the 3 squared, Sam, becomes 9, and the 2 squared becomes 4. That's our first step. Go ahead and take care of those exponents within the parentheses. Now, we can finish off the parentheses getting a 13 times 2 plus 42 divided by 7. Once parentheses are gone, my next step normally, class, would be exponents, but there aren't any exponents left because they were already in the parentheses. So then I'm going to multiply and divide. Here's a multiplication, there's a division. I can do them in the same step. 13 times 2. Ooh, that's 13 times 3. 13 and 13 makes 26. And then 42 divided by 7. Uh-oh. Football season, your team has 42 points. They probably scored how many touchdowns? You're not a football fan, are you? Class? 6 touchdowns, probably, if they have 42 points on the scoreboard. And so our answer comes out to a 32 there. All right? Let's keep working on those multiplication division tables. Any others we need to see? 12 or 13? Anyone need to see either of those worked? 12 or 13? All right. Moving on then, let's take a look at number 14. It says a family of 7 bought tickets to a soccer game. Each ticket was $14.85. How much did it cost for those 7 tickets? Bryson? You're right. That's where we say and is at the decimal.
95 cents.
Good. $103.95 is correct. Number 15. Mike Brown financed a car for $27,576. Plus, his Hardy's paying for the car in 72 equal monthly payments. There's a trend that way, 6 years to pay off your car. How much is his car payment each month here? Corey?
$383.
$383 a month. Questions on that homework section? Remembering, of course, that we have a test coming up on Friday. Just a few lessons, right? Lesson 19 for those watching. So, any questions? All right, turn over now to page 41. Make this correction here. Page 41 in your textbooks. And yesterday, Griffin, while you were gone, we talked about something called a least common multiple. And remember, a multiple is a number that includes some other number. Like if we did multiples of 5, our multiples of 5 class are 5, 10, 15, 20, 25, 30, and so forth, right? Those are multiples. So if we had a couple of numbers, like for instance 5 and 9, and we wanted to find the least common multiple, one way we could do it is to simply list out our multiples. 5, 10, 15, 20, and keep on going. We could also list multiples of 9. Class, say those with me. 9, 18, 27, 36, 45, and so forth, right? The numbers could just keep going. Eventually, if you go long enough, there will be a number on this list that matches a number on that list. That's so inefficient. So I said what we're going to do instead is kind of do what we do for the greatest common factor, and that is to prime factor. Now we could do this in our head class. 5's prime factors are 5. Okay, and the 9's prime factors are 3 times 3. But once we prime factor, instead of looking what they have in common, what they share, we're looking for winners. Who has the most 2's? Who has the most 3's? Who has the most 5's, most 7's, most 11's, most 13's, and so forth? Well, he wins by forfeit, and he wins by forfeit. Because the other guy didn't have any 3's, he didn't have any 5's. So they both win. Everybody's a winner. Participation trophies for all. And so we just multiply all the winners together. 3 times 3 times 5 class gives us 45 is our least common multiple. If we were to look at number 2, we have the number 4 and the number 16. Well, 4's prime factors are really straightforward. Luciana? 16's prime factors are a little much, but whatever. Bryson?
4 times 4.
Well, prime factors, though.
2 times 2 times 2.
Yeah, 4 of those, right? 2 times 2 times 2 times 2. Here, Griffin, we have a clear winner. This has more 2's. This is a loser. Instead of sticking an L on it, we cross it out, okay? And we take the winners. Well, 2 times 2 times 2 times 2 class is obviously 16, which means the LCM is 16. All right, look at the next ones. We have 12 and 60. These prime factors aren't as easy to do in our head, but that's okay. We did them last night. What did you get for 12's prime factors, Sam?
I got 12 or 2 times 2 times 3.
Good, 2 times 2 times 3. And then for 60, what did you have? Paige, do you have that written out? Go find your work. Jalen?
2 times 2 times 3 times 5.
Good, 2 times 2 times 3 times 5. Well, notice, who wins the 2's?
It's a tie.
There's a tie. The 3's, it's a tie. Well, here's the way it works. Just like in baseball, if you don't know if he's safe or out and you're the umpire, you just call whatever feels good at the moment. Because you can't call a tie, right? You can't be like, he's safe and he's out. We can't do that, right? So you have to make a decision. So you're either like, I don't like this team, he's out, or safe because I like this team better. And then of course they go to replay review and all that stuff. But we don't have replay review, so we just pick one. Which one do you like better? These top 2 2's or the bottom 2 2's?
Top one.
You like the top ones. Way to go, loser. All right, but what about the 3's?
Top one.
Oh, call it both ways. Nope. He's definitely playing favorites. Top one, loser. Winner of the 5's. Well, that one's obvious. It's a forfeit win. He's the only one with 5. And we multiply all those together in class. The LCM is 60. So you pick a winner if there's a tie. If there's a clear-cut winner, you pick the winner. Make sense? How many have these first 3 correct for your LCMs? What about for number 4? You had 4 and 18. What was the LCM there? Let's see. Corey.
18.
For 4 and 18, what was your LCM?
18.
Oh, you said 18. Let's take a look at that, Corey. What did you get for the prime factors of 4?
2 times
Good. And then for the prime factors of 18?
2 times 9.
Well, but 9's not prime. We have to prime factor that 9. 9 turns into 3 times 3. Okay, so do you see there's a clear winner of the 2's, loser, and there's a clear winner of the 3's. We got to multiply all those together. 2 times 2
4
times 3 times 3.
36.
Should have had a 36 for our LCM on number 4. Number 5, what did you get for your LCM? Michael, did you do that page?
Yeah.
All right, what'd you get?
Number 5.
Number 5 is?
7. 70.
70 is our LCM. Very good. How about number 6, Kirsten?
90.
90 is correct. Number 7, let's see, Ben.
81.
No, 12 doesn't go into 81. Elaine?
36.
36. And number 8, let's go to Bryson. 75 is correct. Do we need to see any on the bottom row? I know I worked the whole top row. Which one's on the bottom row? You see, I missed that one. Can you show it to me? Jalen?
6.
Number 6. Corey, was that yours also? What do you?
8.
6 and 8. All right, let's take a look at 6 and 8. All right, so check your prime factors first, right? 18, you should have had a 2 times 3 times 3. And for 30, you should have had a 2 times 3 times 5. Okay, did you get the correct prime factors, Jalen, or was that the problem?
I guess I did multiplying wrong.
Okay, so pick a winner. This is a clear winner, and that's a clear winner. And when you multiply all of those together, that's where we get the 90 for number 6. Corey, yours was number 8. We had a 15 and a 25. Check your prime factors. Should have had a 3 times 5 and a 5 times 5. He's a clear winner by default. He's a clear winner, and that's a loser. And when you multiply, that's where we get 75. Does that make sense? All right, questions on LCM? For Griffin's sake, he wasn't here yesterday. You can close your books, just get out some paper. Let's practice a few more of these. Make sure that he has a chance to practice it since he missed out on that opportunity yesterday. I want you to do 10 and 12, then 8 and 12, and then 4, 6, and 10. So we have a couple number pairs, then we have a trio of numbers you need to find the LCM for in each case. Again, prime factor, find the winners, multiply all your winners together. Don't forget to cross out the losers so they don't throw you off. That's correct. Okay, so who has the most 2s? Cross out the loser 2. Who has the most 3s? Yeah, that's default, right? So whatever. And then 5. So take all the ones that are winners and multiply them all. You know what to do. Check your answers to the first 2. Also check your prime factoring while you're at it. For the first one, we should have factored this way and gotten an LCM of 60. How many get to go on the first one that's on the board? For the next one, again, I showed the prime factoring. I showed the winners. Got an LCM of 24. How many had that? For the next one, 4, 6, and 10. How do we prime factor the 4? Ben?
2 times 2.
How do we prime factor the 6, Griffin?
2 times 3.
How do we prime factor the 10 page? All right, who wins the 2s, class?
4.
The 4 does. These other 2s are losers. Cross them out. Who wins the 3s?
6.
Obviously the 6. Who wins the 5s?
10.
10, obviously. They're both default wins. And 2 times 2 times 3 times 5 plus gives us 60 for the LCM. How many had that for the last one? Any questions on finding LCM? What if we were trying to find greatest common factor instead? Well, these both have a 2 in common. That's it, right? So the GCF would be 2. Because they have a single 2 in common. What about here? What do these 2 numbers have in common, class?
2.
2 2s, right? So their greatest common factor would be 4. What about 4, 6, and 10? What do they all have in common, class?
2.
Just a single 2. They all have a single 2, so their greatest common factor is 2. Remember, on the LCM, you multiply all the winners. For the greatest common factor, just what do they all got? They all got a 2. They all got 2 2s, so 4. They all got 1 2, so 2. Okay, it's just a reminder so we keep those 2 things straight in our minds. Look at page 40 in your textbooks, if you would now. Page 40, a couple word problems you want to take a look at. Page 40 in your textbooks. And LCM is a thing that becomes kind of real life. I don't know if you've ever heard those only in America jokes. Only in America do Americans park in the driveway and drive on the parkway.
Huh?
Think about it. Where do you park your car? In the driveway. Where do you drive? Down the parkway. Ah, like Veterans Parkway? A parkway is just another name for a different street, usually a little bit of a larger street that goes through town. So only in America do they have Braille on drive-through ATMs. Think about that for a minute.
No, what did you
Doesn't make
say?
They have Braille on the drive-through
Doesn't make
ATM.
sense. What's Braille?
The little dots, the raised dots that a blind person uses to read.
Oh.
But blind people aren't allowed to drive. Think about that for a minute. Only in America do they package hot dogs in packages of 8 and buns in packages of 10. You know, whatever. Well, that's a problem. Or hot dogs in packages of 10 and buns in packages of 8. Though I have noticed lately, actually, getting more packages of 8 on the buns or on the hot dogs as well. But we've got this problem in number 19 on page 40. Craig is buying hats and shirts. And when he buys a bunch of shirts, he gets them in a 5-pack. When he buys hats, they come 4 to a package. Well, you can't make an outfit that way. You got 1 extra shirt. So you got to buy another package of hats, don't you? Well, now you have too many hats and not enough shirts to match. So the problem is, if we've got 4 hats to a pack, and we've got 5 shirts to a pack, there's got to be a magic number at which we could have an equal number of both. Well, what we really need is the LCM. Most of you could do this in your head without even thinking. What's the least common multiple of 4 and 5, class?
20.
20. We ultimately need a total of 20. So how many packs of hats do we need, class?
5.
How many packs of shirts do we need?
4.
4. That way we have 20 total. We have 20 total outfits of shirts and hats. Does that make sense? Look at number 20. Here we go. Now, I've never seen a hot dog pack with 6 hot dogs. But this is some store brand somewhere that decided that was a good way to do it. Half dozen hot dogs. I don't know. Jack wants the same number of hot dogs and hot dog buns. There are 6 hot dogs per pack, and there are 8 buns per pack. At least that's normal, right? I think I've never seen a package of hot dogs. Well, okay, I've seen the big dozen pack. But 8 buns to a pack, 6 hot dogs to a pack. What's the least common multiple of 6 and 8 here, class?
44.
24. Now, 48 would work, but you'd have a lot of hot dogs and buns. 24 might work better if you buy how many packs of dogs, class?
4.
And how many packs of buns?
3.
3, and that's the least number if you want them to match. Or in my household, you just don't care if they match, because you can always cut up hot dogs and give them to the little kids. What do I do when they get older? I have to start thinking about least common multiples. All right, questions on that? All right, across the page, page 41, I want you to do 9 through 12. Page 41, do numbers 9 through 12. Hey, if you need to do the prime factoring to figure out the LCM, not a bad move. I understand in some cases we could do it without, but some cases you might be duped. Page 41, do the 9 through 12. You already did 1 through 8 in the homework. Finish out that little homework section. Page 41. 9 through 12. All right, pencils down. Even if you're not done with everything, read number 9 for us, if you would, Elaine.
Jordan needs to buy an equal number of pens and pencils. Pens come in packages of 2, but pencils are sold in packages of 3. She wants to buy the least number of pencils possible. A, how many pens will she buy? B, how many packages of pencils will she buy?
All right, so how many pens, and then it says how many packages of pencils. All right, so 2 pens to a pack, 3 pencils to a pack. What's the fewest number of pens?
12.
Ben?
6.
6. So she could go with 12, but 6 would be the better number, which means how many packages of pencils will she end up with, Ben?
Pencils.
2 packages of pencils. How many packages of pens, class?
2. 3.
3 packages of pens. I didn't ask that. 3 packages of pens, so she ends up with 6. 2 packages of pencils, so she ends up with 6. Why does she care so much about having an equal number? I don't know. Maybe she's just that way. Number 10. Read that one for us, if you would, Sam.
10. Julie noticed that there were 10 slices of cheese per packet and 8 hamburger patties per packet. She wants to have the same number of hamburgers and cheese slices. What is the fewest number of cheese slices she can buy? How many packets of these should Julie buy?
All right. What is that least common multiple of 8 and 10?
2.
Well, she can't have only 2 hamburgers if they come 8 to a packet and 10 slices of cheese. She can't have just 2. Bryson?
8.
Sorry? 80, that's a lot of burgers. She could do 80, that would work, but it's a much easier number than 80. Luciana?
40.
40, okay, they just figured it out. 40 is the number we're going for there. So in that case, how many packages of each should Julie buy? Let's come back to Sam.
40.
Well, if you want 40 total, that's how many packs she buys. That's how many total things she ends up with. So how many packs of cheese?
21.
There's 10 slices to a pack. She wants 40 slices. How many packs is that?
4.
4, there we go. And 8 burgers to a pack. How many packs of burgers?
Was it?
5, there we go. And that gets us to the 40. So 5 packs of patties, 4 packs of cheese slices. Number 11, find the greatest common factor. Okay, so change your thinking. We're not multiplying winners. We're finding what they share. For 8 and 24, Jalen.
8.
8. For 13 and 52, what do we get, Luciana? 13. Yeah, as a factor of 52. 2 times 2 times 13. Number 12, are these prime, composite, or neither? Class letter A is? Composite. Letter B is? Prime. Letter C? Composite. And letter D? Neither. All right, questions on those? I got 3 numbers for you. 8, 20, and 28. You can go back to just your paper. I need you to find, obviously, the prime factors, and then tell me what is the GCF and what is the LCM. I want you to find both of them. Prime factor first, then use them to find both the GCF and the LCM. You can set your books aside now. Just working this problem on your paper. Prime factor, go. It's been a little while since I've shown division of primes. My personal preference is the factoring tree, but I went and showed it just for variety's sake here. How many got for your prime factors today? 2 times 2 times 2. For 20, 2 times 2 times 5. For 28, 2 times 2 times 7. We should be automatic with prime factoring. Now here's the key. Greatest common factor class, I'm looking for what they share. You might want to make sure you just have that word associated with GCF. What do they share? Well, what do they share, Griffin?
2 2s.
They share a pair of 2s. So therefore, the greatest common factor is 4. How many had 4 for the GCF? All right, for LCM class, I don't care what they share. I'm looking for winners. That's what you need to be looking for. And the winners get multiplied. Make sure we remember that. We're not just identifying what are the winners, but we actually multiply them together. Well, who has the most 2s, class? 8. Winner. Losers. Cross them out. Winner of the 3s? There aren't any 3s. Winner of the 5s?
20.
And 7s?
20.
And we multiply 2 times 2 times 2 times 5 times 7, class. We get
280.
280 for the LCM. And how many had that? Questions on GCF LCM? Yes, sir.
I guess somehow, instead of circling 8 for the, since they had the most 2s,
Mm-hmm.
I accidentally circled 28's twos, and then I didn't circle the two, I crossed out everything but the two on the 8. The third two, I didn't cross that out.
And you end up with the same answer?
Yeah.
It's a weird way to do it, Michael. I wouldn't recommend doing that. It's probably going to lead you astray. Does it make sense? All right, questions. All right, clear test except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Get a test coming up Friday. Let's take a quiz now. Give me one more chance to make sure you got it. Give us a chance tomorrow in our review to clear up any questions that you might still have. But I want a chance to make sure we're going to be good for the test on Friday. So clean sheet of paper, pencil, everything else away. Yes, sir. Sure. As long as it's blank, as in nothing written thereupon. Yeah. Graph paper is fine. All right. Everything off your desk except for paper, pencil, everything else away. We will be taking quiz 3. Quiz 3. For those watching on YouTube. All right, come quickly, Sam. Quickly, put that binder away. See me after class, Sam. Make sure you take care of that before class starts. Yeah. All right, when you get your quiz, put your first and last name in the name spot. Today's date in the date spot. First and last name in the name spot. Today's date, just a blank sheet of paper, not a spiral notebook. So just tear these out right here. All right, first last name in the name spot. Today's date in the date spot. Let's take a look at our quiz together. Numbers 1 through 6. They've given you a pair of numbers. First, you're going to find the GCF, and then you're going to find the LCM. Then go to the next pair of numbers, GCF, LCM. Next pair of numbers, GCF, LCM. Okay, so you're going to get to use those prime factors a couple times. Do make sure you show those prime factors, just in case you make some careless mistake. You want to make sure you get that. Numbers 7 through 10, order of operations. They give you space to work it out. Show your steps. Show your work. Be careful. You may begin. Use that blank paper as a cover sheet. So as you finish problems, cover them up. minutes to be finishing. Just in the video. Finish it quietly. Go collect those from you at this time, along with your scratch paper. If you used scratch paper, if you didn't, that's fine. You don't need to collect that. I got your homework assignment pads out just long enough to write down a reminder to yourself that we do have a test coming up in lesson 19. Test coming up in lesson 19. It will be covering sections 1.1 to 1.8. So basic things about numbers, place value, add, subtract, multiply, divide, working with decimals, shortcuts to dividing when there's zeros, multiplying when there's zeros, things like that. It'll have order of operations on there. It'll have absolute value stuff on there, different types of numbers on there. It'll have obviously greatest common factor, least common multiple, stuff we just had on this quiz, order of operations I just mentioned. Yes, ma'am?
Is it Friday?
Yeah, coming up Friday, yes. Test coming up on Friday.
Could you repeat what sections?
Yeah, sections 1.1 to 1.8. Sections 1.1 to 1.8. So we will be reviewing tomorrow. We'll take a look at that quiz tomorrow as well. All right, question, Michael. You can't ask something about the quiz while we're on video. But you can ask me right after class. All right. All right. When the bell rings, you'll be dismissed. You have a wonderful rest of your day.